So good afternoon, everyone. I hope you can hear me. This afternoon's Google Hangout will relate to week 3 of the module relating to data analysis using SigmaPlot for biomedicine. So I know many of you have worked through the material now for weeks 1 and 2, and slightly fewer have used the material for week 3. That's fine. You can take this course at your own pace. And the material will be available for a number of weeks yet. So you can work through all 6 weeks' content at your own pace from home as you please. Next week's content is analysis of variance. So it gets a little more difficult. So I'd recommend that you continue working through the material at your own pace and recognizing that after this week, it does get a little bit harder. So if you found it a little too easy so far, you'll find that it gets more complex in the last 3 weeks of the material. So I thought I would just show you how to do some of the analyses that you've been hearing about in the module so far. So if I share my screen with you, what you can see here is the 2 data sets that you'll encounter in this week's material. So the first is here. And this is example 5, non-normal data. Here we go. So all the data that you will discover in this week is not normally distributed. And what that means is when you plot the data, for example, here, response time for male and female mice, you'll see when we plot the graph, there are lots of values that are near 0. So they're all bunched up at one end of all the possible response times. So if I click on analysis and click histogram, you can choose to plot the response times to see how they're distributed. And you just click finish, and it's going to generate this histogram. And as we just mentioned, you can see a lot of the values are clustered around 0. There are very few intermediate values, and then there are some higher, slower, longer response times. So when you see a histogram like this, the first thing you should realize is it's probably not suitable for analysis using a t-test. If we go back to the experimental design, what we have here are 2 groups of mice, male and female, and we want to know if they differ in their response times. So by plotting the histogram, already you'll be suspecting that you can't use a t-test for this kind of experiment, and that you might need to use an alternative test. And where the distribution isn't nice and symmetric with a big peak in the middle, one often thinks that you should use a non-parametric test. So let's see. Really the lesson from this week's material is that SigmaPlot is going to help you make the right decision. Okay, so suppose that you wanted to try and plot a t-test using this data. So you go to the the test menu, and you select t-test, which is the unpaired t-test, because we only measured each male and each female mouse once each. You click run, and it asks how the data is arranged, and you say we have it in the indexed format, which is what we use throughout this course. And you click next, and it asks where your group is. Well, that's your factor, gender with 2 levels, male and female, and your response times are in this column here. If you click finish, as we suspected, SigmaPlot has noticed that the data doesn't appear to be normally distributed. If anything, it's bimodal, and certainly there are lots of values near 0. So you don't need to panic when SigmaPlot gives you a warning message. I just recommend that you follow its advice. So in this case, it's suggesting that you might want to run a Mann-Whitney rank sum test instead. And so I recommend you follow its advice. And then when you see the report window, what it will say here is that your data failed the normality test, and instead, SigmaPlot recommended that you run the Mann-Whitney rank sum test. And you don't need to worry too much about the details about how this is calculated. You can read more about that through the help menu up here, or through the manual, which we've made available for you to download through the module. The key fact that you need to report is that the difference in the median values between the 2 groups is greater than would be expected by chance. It's saying there's a statistically significant difference between the groups. And that this is your p-value, so it's small, it's less than 0.001. And so there's nothing really to worry about. SigmaPlot is going to help you choose the right test, and then it's going to tell you what the result is. And so if we go back to the module, what you'll find is the module will give you additional advice on how to plot this kind of data. So if we go to week 3 content and click here and scroll down, you could plot this kind of data using a scatter plot or using a bar chart. So for example, if you wanted to plot a scatter plot, you could click here, and there'll be a little video which will tell you how to plot this kind of data using a scatter plot.
So you can see here that the male values, the male mice, have longer response times than the female mice.
So this is an example of a scatter plot, and this movie will show you how to generate the scatter plot. And then also if you click on panel 8, it's going to show you how you could plot the individual points, the individual data points, or a box plot.
This is here. So if for some reason it won't open where it says results graphs, then
well, I won't play the whole video, but you'll find if you click here, you can listen to the video and it will show you how to plot a box plot. So that's the first half of this week's content. It relates to the Mann-Whitney test and how to analyze data that doesn't appear normal. Then in the second part of this week's content, you'll learn about a different test, which is called the Wilcoxon assigned rank test. And this is a test you can use for paired T-test kind of data, which where the data is not normally distributed. And so if we go back to Sigma plot, there's actually a mistake in the videos. And what you want to look for this data set for the Wilcoxon analysis is example 19 data, which you'll find here on the left-hand side. So you need to double-click example 19 data, and this is the data here. And if you click histogram, and as before, we say the source data is in this column, and you click finish, this is the histogram that you get. Now, it doesn't look too bad. It's relatively broadly spread. There's not an obvious peak in the middle, but there's not too many low values like zeros, and there aren't too many very high values. So it's broadly symmetrically distributed. But let's try to analyze this data using Sigma plot's advice. So in this experiment, a doctor measured the size of a tumor before and after a treatment called Shrink It. And the doctor did this in a variety of patients who are labeled A, B, C, D, E, F, G, and so on through to K. So this is a classic repeated measures design where the same patient, patient A, has been measured before and after on the same thing. That's the size of their tumor. And what we want to know is whether the treatment shrank the tumor. So in other words, was the tumor smaller after treatment than before treatment in all these subjects considered together? So if you try and run a paired T-test for this, let's see what happens. So you click run, and it asks how your data is distributed. And again, we will select the indexed format because that's the format we're predominantly using on this course. You click next, and it asks where are your subjects? Well, here they are. You click subject. Then it says, where's the column which defines the treatment or the factor? Well, it's in this column, before versus after. And then your data are in this column here. Let's click finish. Okay, so in this case, Sigma plot was happy that your data appeared to be relatively normally distributed. And you can see that from the graph here. And so what you would want to report would be your two-tailed p-value, which is 0.0131. So here that says that the change that occurred with the treatment is greater than would be expected by chance. There's a statistically significant change. So you could also try to analyze this data using the Wilcoxon assigned rank test. And to do that, you would go back to the data, you would find the drop down, and you'd scroll down, and you'd find the Wilcoxon assigned rank test, which is assigned rank test, which is here. And if you click run, again, Sigma plot is going to ask you how your data is arranged, and we'll say indexed. Click next. And again, it says, where is the subject? Well, the subjects are in this column, the treatments are in this column, and the data are there, and we click finish. So in this case, Sigma plot is actually trying to help us. It's saying, well, actually, a normality with test was passed, so this data could be analyzed with a paired T-test rather than the Wilcoxon. So in general, you should follow Sigma plot's recommendations and click yes. And if you do that, again, Sigma plot has given it's moved to the paired T-test, and it's given you the same p-value that we saw previously. So although this kind of data before versus after could be analyzed with the paired T-test or the Wilcoxon assigned rank test, Again, SigmaPlot is going to help you make the right decision about which test to run. Okay, now if we go back to the module itself, when you have data of this kind, you can plot repeated measures data using a line graph. And if you click page 13, this little movie will show you how to plot the line graph. And then that would be a line graph for all the group's subjects together. So these would be all the subjects before the shrink it treatment, and these would be all the groups after the shrink it treatment. And then finally, if you click on page 15, this will show you how you can print each person's line. So person A, person B, person C, and so on. So you'll see the change for each person one by one. So I hope this has helped you navigate the content in week 3. I'd encourage you to work through this at your own pace so you gain confidence in using SigmaPlot. And then next week we'll see how to use SigmaPlot to analyze more complicated data sets, such as using the analysis of variance. So I hope you find this module useful, and I look forward to sharing week 4's content with you next week. All the best.